Okay, so this video is to go over the exponential properties. This is going to be a review from what you guys did last year. I know you've got variables in here, but the properties are still the same. They're going to work the same way. So first things first, let's go over, there's 5 of those properties, right? First one is negative exponents. And that basically just means that if you have 5 to the negative 2, that's the same as 1 over 5 to the positive 2, right? Same thing. And same thing as if you had 1 over 5 to the negative 2, that's the same as 5 over, or 5 to the positive 2. Basically, old man scenario, right? It just goes downstairs or upstairs, changes attitude. You just flip them over the fraction bar to make those exponents positive. Okay, next one is the zero property of exponents. And that basically just says anything to the 0 power, no matter what it is always going to equal 1. Okay? Again, if I did 5,000 to the 0 power, it's still just going to be 1. No matter what, anything to 0 power is going to be 1. Okay? Then we've got our multiplying property. And what that basically says is if I have two exponents, numbers with exponents that are multiplying, x squared times x to the 4th, that's the same as saying x to the 2 plus 4, which is equal to 6, right? You don't put a 2 in front of the x or anything like that. All you do is just add the exponents. Okay, if it's the same base, you can just add the exponents together. Next one we're going to talk about is the dividing exponent rule. So that, again, using the previous example, x squared over x to the 4th is the same as the top exponent 2 minus the bottom exponent, which would be x to the negative 2, or 1 over x squared. Okay? So again, with that one, you just subtract them, where with multiplying, you add the exponents, dividing, you subtract. And it's always the top minus the bottom. Okay? And then the last one, we have our power of powers. Okay, that's when we have something like this. X squared being raised to the 4th power. So when you have something like that, you are distributing the 4, or whatever's outside the parentheses, to the exponents inside. So that'd be like 4 times 2, which is x to the 8th power. If I had something like this, x, y to the 2nd, all to the 3rd power. Again, you're distributing to all the exponents inside, so 3 times 2, but also this x would have an exponent of 1, right? Everything has an exponent. So you got to make sure you distribute to both of those. So you would get x, 3 times 1 is 3, 2 times 3 is 6, so that would be your answer there. Okay, those are the 5 properties that you got to remember. Again, negative flips over the fraction bar, 0, everything becomes 1. Multiplying, add the exponents. Dividing, subtract the exponents. Power of powers, you multiply the exponents. So let's look at some examples here, see if we can figure this out. So, number 1. So, it's kind of a mess of a problem, but we have m has another base down here. So I could do a dividing. I can't multiply these because they're not the same base. So I can't simplify on top. This 4 doesn't have anything. So the only thing I can do is combine these m's. So again, since it's dividing, it would be like m to the 2 minus a negative 2, which would become positive 4, right? So since positive is going to stay up front, up top, so it would become m to the 4th times n to the 2nd. Now that -2m basically moved up top, so it's no longer downstairs. The only thing left downstairs is 4. And that's all I can do to simplify this. So that's my answer. Okay, let's look at another one. So let's look at number 3. So these constants, they divide into each other, right? 4 times 4 is 1. So basically they're going to go away. Okay, now x has a base down low. It's -4, so it'd be like x to the 4th minus a -4. Minus a negative, it's like adding. So I would get x to the 8th and then y to the -3. It doesn't have a base, but again, I can only have positive exponents here. So, according to this worksheet, so that y would go downstairs, become +3. And that would be my final answer there. Okay. Let's do another really big one down here. Whew. Yes, let's look at number 11. So number 11, there's a lot going on here. Generally, with the exponent rules, you kind of follow the order of operations. So parentheses, do everything in the parentheses first, then multiplying, then exponents, then multiply, divide, blah, blah, blah. So I'm going to do everything I can inside these parentheses first. Okay? So the top, I mean, I can do stuff about that, but let's worry about this bottom first. So let's get this multiplying bit out of the way. So when I multiply, again, it's just like multiplying your like terms. So these constants in front would all multiply. So 2 times 2 times 2 would be 8. I'm just going to rewrite this because it's the only one I'm changing. 8, and then a squared and a to the -4th. If I'm adding those together, because that's multiplying, 2 plus -4 would be -2. So a to the -2. Then b's, I have -3. +2, -3 plus 2 would be -1. And then +1 plus -1 would be 0, so the b's go away. So all that I'm left with after I multiplied is 8a to the -2. And that's still over 2a to the 3, b to the -1. Okay? So, first of all, if I were to take out the 2 here, that would leave 2 times 4a to the -2, right? Yeah. So the 2's would cancel out. Then 3 minus a -2 would be +5. So I'm going to rewrite this over here. A to the 5th, and then I would move the b downstairs to join my 4 because it's negative. And after all that, that's all that's left inside my parentheses. Whew. But I still have a power of powers. So again, this power of powers has to multiply with all the exponents inside. So I'm multiplying it to that 4, to the 5, and then to the 1 above the b and the 1 above the 4. So 4 to the 4th power, it's a big number. Oops. 4 to the 4th is 256. So I'm going to get 256 b to the 4th, and that's all below a to the 20th. And that is my final answer. It's kind of a lot, but you guys can do it.